All right, here we go. Anyone have any questions before we get going? Nothing? Not a one? All right, we're getting going then. So last time we spent kind of brainstorming on this Joust project and came up with a bunch of general notes on what comprises the game, and also we began identifying abstractions, and the obvious two to come out of it was the knight and the weapon. It was also fairly straightforward. It isn't always easy to get all of them, but relatively speaking, it was straightforward to come up with the attributes that would comprise each of these abstractions. That a knight has a name, some sort of reserve of stamina, whether or not they're on the horse, and then a knight has a weapon. Again, it's right there in the notes from last time. That's referred to as composition, or has a relationship, because a weapon in and of itself is its own abstraction. And for that we have the type of weapon, the stamina that it depletes from the user of the weapon with each use, and the chance of hitting the opponent. I'll throw another one in here that you don't have to write, but one that you'll use and is relevant to this project. So diving down into the course shell here at the projects, and if we look at project 4, talk about this random class. Now this is a bit of a switch up for us, in that in previous projects, whenever we've needed a random number, we've used that rand function, and we've used srand to seed the random number generator. And now I'm giving it, those functions are still being called, but they're actually being wrapped up to this class that I'm providing to you, and we'll use this class rather than using rand and srand directly. So you don't want to use rand or srand directly, you want to use this. Let me go ahead and demonstrate that real quick. So let me quit out of here, let me run this command after I've downloaded it, and that's going to be in my downloads. Alright, it's just got two files. You're not going to modify either of these files. You never even need to look at the contents of random.cpp. There's stuff in there, but if you're using a type that someone else created, there's really only one thing that you're interested in, and that is whatever's in the public area. So I can look at random.h, that describes the class, and that's it. That's all I really need to know to use the thing. You don't need to know anything about private, you don't need to know anything about how it's implemented. All you need to know, in this case, are these two functions. So those two functions, we'll test random. Let's write a little program to test it. Line 9 is a constructor. It is the way in which we create random objects, and in this case we provide it with two numbers, a low and a high. So I will say that I want to create a random object, Randy, and the low will be so for this particular Joust project, we need to deal with probabilities, and rather the probabilities, of course, are between 0 and 1. We're just using them as percents instead, so anywhere from 0% to 100%. We'll just generate a random number between 1 and 100, and that's how you create the thing. How you use it, again, this is just a test program to show that we can use it, so I'll create an integer I is less than 10, plus plus I, and let me go ahead and int the number equals, and I'll call Randy. And now looking back here on the left pane, in addition to creating it, the only other interaction you can have with a random object is to say get. Doesn't take any information. You can ignore the const. We haven't talked about that. I don't think we even talked about it in 111 at all. So for our purposes, you can ignore that it's present. And it's called get, and it returns an integer. And presumably it returns an integer between 1 and 100. So I say get, ask Randy to get, right? I can create Randy. I can call the get function on Randy. And then for this, do that. We'll end the loop. So let's test that out. You'll create a makefile for the Joust project ultimately, but for the sake of this test program, actually let me do it wrong first. Let me change this shell prompt. Anyone know why I always put bash there? Anyone curious? Is it because I'm into fighting words that are kind of in spiky bubbles in comic books? Bash pow. Yeah, bash is referring to the program that is producing this prompt that I interact with. It is the name of the program is called bash. It's taking my keystrokes and interacting. For instance, bash you can see it right there. Bash is saying, hey, I don't know what FDSA is. So that's my only motivation. You can put anything you want there. Okay, so let me do this wrong. I'm going to test random. And my question to you, whoops, I have a different error. Not the error I was looking for, but that's fine. All right, here's the first error. Use of undeclared identifier random. It doesn't know what this is. So let me come back to my program. It doesn't know what this is. Why doesn't it know what this is? Before you can use it, you have to tell the compiler what it is. Random.h contains the information describing to the compiler what a random thing is, should we decide to use it. All right, now we'll get the error I was hoping for. Let me make that full pane. So I had a video tips thing, I think, on the 4 steps to the compiling process. This would be relevant to that if you can remember any of that. The key here is that this is a linker error, meaning that the program compiled just fine. The compiler dealt with that just fine, but the problem is that it was unable to find the source code to this function, and it was unable to find the source code to this function. Where is the source code to that function? It's in random.cpp. So when I compile this thing, I need all CPP files compiled together. It goes the other way around. What if I put random and I don't put anything else? Anyone want to guess? I will get a linker error again, an undefined symbols error. Does anyone know what will be undefined if I try to create a program out of that? It has that random constructor and it has that get function. What's it missing to make an application that runs? Main function, right? Let's see. There you go. Undefined symbol, main. So we need both of them. The random functions plus the program that contains the source code that contains the main function. Oops. Run it again. Different set of numbers. Just to, whoops, I have that open over here. Just to show we can make it a bunch of numbers between 39 and 40. I don't know why you would want to do that, but just to show that we can. 39s and 40s. Okay, so the thing works. So that's what we're going to be using for the Joust project. Whenever we need a random percentage generated, we'll use that. All right. So coming back to the Joust notes, identifying the attributes of these abstractions is fairly straightforward. What's a more difficult proposition is identifying the behaviors. And what is provided as a mechanism for being able to draw out those behaviors is this delightful thing right here. This is called a sequence diagram. It is a thing. I've had more than once, I've had 111 students do this, and then I talk to them 2 or 3 years later after they've had like a summer internship, and they say, you know what we did? We did sequence diagrams. So it's a real thing, and it's actually used in industry. It's not something I made up, and it's not gratuitous, right? Something you wouldn't do if you weren't in a classroom. The idea here is that you're drawing out a sequence of events in the application. Now, in a large application in the real world, there may be hundreds of these sequence diagrams, each one covering just a particular sequence in the application. Turns out that Joust is simple enough that probably 90% of what we need can be covered in this single sequence diagram. What it represents is these up here represent objects. They don't represent classes. In fact, I'm going to want some volunteers up here. We are going to role play the primary Joust sequence, and while we are doing it, I will draw that stuff on this diagram so we can see it happening up here on stage and also see it happening in diagram form. And then what we're going to do after we do all that, we're going to show how this diagram actually converts to code. Okay, so we're taking it soup to nuts from beginning to end. So as a start, and if you thought things were exciting already, now look at it. Now it's becoming real now. But I'm just going to keep it on me, even though you're up here. All right, no, that's a joke. So give me a moment. I have to start moving things around on my screen so we can get it all up at once. Let's see, I can minimize it. I can close that. All right, we're getting closer. Now I have a risk here. Sometimes when I turn my computer, this HDMI cable comes loose, and if that happens, my recording stops. So if there's a stutter in the recording, that's the cause. All right, so what I'm going to need is I'm going to need 5 volunteers. You don't have to raise your hand. You just have to walk up and be on camera. Look, this is fantastic stuff to show your relatives over Thanksgiving, and that is coming up. You're going to want to be up here to show them that you're getting a good education, all right? 5 people. 2 knights, 2 weapons, and then there will be something that represents the main program, kind of the ringmaster running the show. All right, we have 2. That's good. We're 2/5 of the way there, and I do have a full half hour to sit here in silence until I get 5. All right, I have 4. Good. 1 more. It looks like we have 2 knights and 2 weapons. I need a ringleader, not a ringleader, a ringmaster. Maybe a ringleader. It's kind of a gang of sorts. Someone who wants to be the main program. I see a couple people, they're looking down at their computer, not looking up. Come on, someone, I will pick. There's a, come on. There we go. If you make eye contact, your fate is sealed. All right. I'm going to take this off. Okay. Why don't you give me the ringleader so you can stand in the center there. All right. So I've got these file folders with sheets of paper on it again. We're going to do the same kind of thing. Now what I want to do is I want to create 2 weapons and 2 knights. And each knight has a name. And each knight has a stamina. And each knight has a I guess that's it. Each knight has a weapon, but I don't want to put that on the sheet of paper because they're actually separate. For each weapon, there's a type. Each weapon has a, if I come over here, a stamina depletion. So let's see, stamina depletion. And a chance to hit. Chance to hit. Let's do that for the second weapon. Type. Stamina, I'm going to have to abbreviate. I should have abbreviated the other one. Chance to hit. All right. I'll have my folks on the outside be the weapons. The folks on the inside be the knights. You're the weapon. You're the knight. All right. So the first, look, go ahead and hold up your, don't be writing on them yet. Don't write on them yet. Hold them up. Got to have some audience participation here. Okay, they're blank, right? So let's go over again. When this thing starts up, where are these values coming from?
The program.
Let me. In this case, they're not coming from the programmer. So who are we doing the program for? For the game designer, right? Or designers. It was, what was it? Joe and Martina or something like that? Tom and Martina? So Tom and Martina are going to sit down and they're going to start it, and then they're going to enter all this information so they can test out a set of values, and then they'll see how that joust works, and then they'll run it again and they'll enter in a different set of values and see how that works until they can come up with a set of balanced values, right? So we have to have the designers enter that information. I'll go ahead and start off. I like to choose the knights' names. I find that sometimes you all choose naughty names. I'm going to keep it G-rated. So some people are just sensitive to words. Like, I don't know, my wife the other night, she got really upset when I used the word puke. But, you know, to me, that's what her dinner tasted like. All right, let's make one night, your name be Stormy, and the other night, your name be Starry. And let me go ahead and write those in. So this is a bit of a challenge. So actually, I'm going to type them in. So I have Stormy. We have Starry. We have, okay, you all can choose what kind of weapons do our knights have? Sword. I think that's excellent. Good standby. What joust would not have a sword? So why don't you be the sword? Or excuse me, you be the sword. And one more weapon. You're Stormy?
I am.
All right, Stormy and the sword, Starry, and what's it going to be? Pike. Pike is good. All right. Last semester, Starry had a dead bug, so I like Pike better. Okay. All right. So the way this sequence diagram works is you don't put classes up at the top. You put objects up at the top, right? It isn't knight, weapon, knight, weapon. It is a particular knight or a particular weapon. That's key to doing these diagrams. So the program start, I'll go ahead and write main here so that we don't lose track of that's what this thick line is representing. Again, a large application may have hundreds of sequences. It isn't always main on that left thick line. It is something outside of the main objects, kind of interacting with the objects and controlling the sequence, whatever that is. In our case, it happens to be main. So what's happened is the designers have sat down, they started running the program, they type in, if you count this up, there are 10 attributes being entered. When those 10 are entered, there is a knight and its weapon created, another knight and its weapon created. Now the joust is ready to begin. What is main going, let's say it starts with Stormy. What is main going to ask Stormy to do? Well, let me actually back up just a little bit. When does the joust end? When stamina equals 0 or the guy's been knocked off the horse. All right. Rather than saying stamina, what does it mean for stamina to be less than or equal to 0? And what word was used by the designers when the knight's exhausted, right? So the joust should only continue if neither knight is exhausted and both knights are still on their horse, right? So we can imagine a loop where we keep doing this over and over again and we ask those 4 questions. We ask Stormy if they're exhausted and are they still on their horse, and we ask the same questions of Starry, and then we only continue the joust if everything comes up with the answers that we want. So I want to represent that in a diagram here. Main begins by turning to Stormy and saying, actually what I'm going to do is I want to have more of a line. So I'm going to start the questioning with Starry. All right. So again, just to get you to say it one more time, what are the 2 things that we need to ask Starry? To decide whether the joust should continue. Are you exhausted? Are you on your horse? So let me get this text tool here. Change it to blue. Are you exhausted? And if you all could shift just, I'll try to keep out of the frame. If you can make sure you're all in frame, pretty soon I'm going to let the action begin here. When Starry is asked that question, what does Starry do? Huh? Oh, I have to pause. We haven't finished the designers typing in all the information. We've got your names and types. let's say that both knights have stamina of 10. Let's say that the sword will deplete, I don't know, 6 stamina. And the chance to hit for the sword is 15%. And for the pike, we'll say the stamina depletes 4. And the chance for the pike to hit is, I don't know, 20%. All right. So we ask Starry, are you exhausted? Starry is going to return something back, and the way you represent that return back is with the line going this way. Now, the line is not solid, though. The line is dashed. What is the, so we have to get the middle bit, but let's look at the end game. When Starry is asked, are you exhausted? What is the nature of the answer? Yes or no. If we turn ourselves into nerds, it becomes true or false. Yeah? So what I'll do is I'll just put it right here in the middle of the line. I'll just say that either true or false is going to be returned. Now here's the question. What exactly does Starry do when the question is asked, are you exhausted? In order to give a true or false, what does Starry have to do? Has to return a Boolean, but tell me about the behavior. What intelligence is going on behind the scenes? Stamina is less than 0. So let me actually type that in. Oops, already there. If stamina is less than or equal to 0, I'm just going to leave it that much. So I, again, don't have a lot of real estate. So if the stamina, are you exhausted? If the stamina is less than or equal to 0, true is returned, otherwise false is returned. Everyone buy into that? All right. What's the other question that's asked? Are you on your horse? Text. Now we already have represented right here a variable that holds that. What kind of variable do you think this is? Just a Boolean, right? True or false. Whenever the game starts, that variable is probably going to be set to true automatically. Yeah, that makes sense. When the game starts, both knights are on their horse. Otherwise, it's going to be a real short game. So here, then, we basically have something similar where we say, if, oh, come on. If the, I'll say, I like that one, on horse is equal to true, and then we go ahead and have another one of these dashed lines coming back. All right. And this will be returning either true or false. All right. So just start this off, and so we can see what it looks like. Let's see if you all know how to role play what is happening here so far. So who's main? You're main. All right, main. Go ahead and start the interaction.
So, are you exhausted?
No, wait. So that's good, but you gotta be a nerd. So it's not no. It's false. Right? And so why don't you say out loud what you're doing? So when you're asked if you're exhausted, what are you looking at? What's the question you're asking yourself? Right, you're asking yourself if the stamina is less than or equal to 0, right? All right, so go ahead and hold that so everyone can see it. And let's start again. And action.
So are you exhausted?
False.
Are you on your horse?
True.
All right, that's good. Okay, so I don't have a lot of vertical real estate here, so I'm not going to repeat this, but this exact same sequence happens in the other direction, right? Before we can even start the joust, those questions have to be asked of both knights. Everyone buy that? All right, so all that happens here. I won't even put any sort of notation, but mentally make a note that it's repeated for Stormy. And now we're ready to go. The questions have all come back the way we want them. We can go ahead and do a round of the joust. So what should main do? Pick someone to do something. Absolutely. What's in human terms, what would you ask one of the knights to do? Attack. So the weapons have already been chosen and all that. That relationship's all set up. So I like attack. Attack's good.
Does that go for both knights at the same time?
That's an excellent question. Does that happen for both knights at the same time? So first of all, what does, just for variety, what I'll do is I will go to this knight first. Come on. The documents that we have does say that two knights come together simultaneously, right? But I have no way in code to write code where they actually simultaneously come together. So here's the analogy. I call you up and I say, roll a pair of dice and tell me what the total is. But you only have one die. Do you throw up your hands in despair and say, I can't do it, I only have one die? Or how do you, quote, fool me and make it look like you rolled two dice at the same time? Yes, you roll twice, right? Roll a die, roll a second time, add them together, and then you tell me the total. That's exactly what we'll do here for the knights to come together simultaneously. We will ask one knight to attack, then we'll ask the other knight to attack. And then we go ahead and start another round. Okay? So both knights always get a chance to attack regardless of the outcome of the first knight. So if this first knight says attack and happens to knock the other one off the horse, the other knight still gets a chance to attack because they're, quote, coming together simultaneously. Yeah? All right. So we'll put attack here. I'll put this in tidy prose. All right, what are the things that happens when you ask a knight to attack? Say it again, loud. The probability of hitting, right? So there's that happening. What's the other thing that happens? Stamina gets reduced, right? If you recall, by virtue of every use of your weapon, you are depleting your reserve of stamina. Let's start with that. What should the knight do then to figure that out? No, first, hold up your cards. The Starry Knight, just looking at the cards, when Starry Knight uses the pike, how much should the stamina be depleted by? 4. All right, so give me a sequence. Main has just turned to Starry and said attack. What does Starry do now? Decreases the stamina, but how does Starry figure out how much to decrease the stamina by? What does Starry have to do? To get the stamina cost from the weapon. So give me an interaction between Stormy and the sword. Get what? Get the stamina depletion, whatever we called it. So let me type that in real quick. Get stamina depletion. I'm just going to abbreviate. Oh, this is still okay. Okay, so when the sword is asked to give me the amount of stamina you deplete by, then what does the sword do? Returns the value. Yeah, real straightforward. So this is another dashed line. Note that every return statement in the language ends up being a dashed line. So I will put the number 4 there. Now let's see if I can do a different 4 there. And then what does Stormy do? Oh, I'm sorry. I'm mixing up weapons, right? And knights. I was working with Starry. Now I'm working with Stormy. So for you, it was 6, wasn't it?
Yeah, it was.
All right. So let me change that to a 6. And then when the 6 comes back, what does Stormy do? Subtract 6. So we put stamina minus equals, in this case, 6. Whatever the number was that came back. Now, what does Stormy do? Stormy's asked for the stamina that it depletes by, got that information, reduced the stamina, and then what? Well, what's the next thing? Someone said it early. There are 2 things, reducing stamina and the hit chance. So what is the interaction between Stormy and the sword? Say it again. It is 50. Where does 15 come from? So give me an interaction between Stormy and the sword. Get hit chance. All right. I'm going to put this in red. So I want to talk about it a little bit. So there is a get hit chance. That number gets returned, right? That's a 15. Then what would Stormy do with the 15? Do something with the random number, right? So we'll talk about the actual interaction with the random number, but the Stormy could then interact with the random number, get a random number, and decide whether or not it's less than or equal to 15. Yes? Here's the alternative scenario. Stormy asks the sword, did I hit? And the sword interacts with random and gets a random number between 1 and 100 and compares it to 15 and returns true or false. So the 2 possible scenarios are, there's an algorithm here. And it's really charitable for me to call it an algorithm because it's just 1 line of code essentially. But it is getting a random number and comparing it against the hit chance. Should that happen in Stormy or should that happen in the weapon? I hear 1 for Stormy. Anyone else want to? See, the problem is I'm pressed for time. I normally do a little anonymous poll and find out what you really think. But Right, so here's how I would work through the thinking on that. That is a behavior. Is the behavior working on one of our object's attributes? Whose attribute is it working on? It's working on the weapon's attribute, right? The algorithm to generate a random number and compare it against the hit chance. That is working on the weapon's attribute. So in the spirit of abstraction and encapsulation, remember you encapsulate together the data with the behaviors that operate on that data. So in the spirit of that, it is better to simply ask the weapon, did I hit? I'm going to just write it quickly. Did I hit? Now, what does the weapon do when the weapon's asked that question? What's the first thing the weapon has to do when asked that question? Compare it to the random number. Compare the hit chance to the random number. You get the random number from that random object that we looked at the beginning of class. What are the two things you can do with the random thing? You can create it. What was the other one? Get. That's it. That's the only thing. And guess what? Here I am, Todd Rand, in my little kindergarten handwriting. All right. So the weapon then turns to me and says, get. And then I'm going to return a random number between 1 and 100. All right, so that's actually a dashed line, believe it or not. I'll just put like between 1 and 100. And then now that I've given the weapon a number between 1 and 100, you say if that random number, I better type it. If that random number is less than or equal to the hit chance. Yeah? And the color of the ink is wrong. Not blue, but that's all right. Just throw it there. And once the weapon has that information, then what does it give back to Stormy? Stormy said, did I hit? And then what does the weapon say back? True or false? Exactly. So I'll just put a quick true or false here. And again, this is a dashed line because it's returning. Once Stormy has a true or a false, what does Stormy do with it? Let me ask a different question. What was the original thing that Stormy was asked to do? Attack, absolutely. And so that's just a response to the attack. Oh, how can I hide this thing? Oh, yeah, zoom in here for a minute. Okay, and so that's returned. That true or false? What if so when main turns to Stormy and says attack, and true or false comes back, what if true comes back? Knocks the other person off the horse. Okay, let's start role-playing it. Let's take it from the top. From the top. Go ahead. Main, begin the whole sequence.
Are you exhausted? Are you on your horse?
Oh, wait. Oh, damn it. Don't want to miss this. Okay. Are you exhausted? False. Are you on your horse? True. Okay.
Are you exhausted? False. Are you on your horse? True.
All right. Everything's come back the way we expect. Let's begin a round of joust. Go ahead and begin.
Attack. Attack.
So you're asked to attack, so what do?
The weapon, choose weapon, attack.
Right here. You're asked to attack, and then you say to the weapon, get the amount of stamina you deplete by.
6.
And then, what happened? What does the knight do with the 6? Subtracts it. Go ahead and subtract it, right? That's right here.
Return 4.
So you don't return 4, you just do the math. You go ahead and subtract the 6 from 10, and you end up with 4, right?
Yes.
So scratch out the 10 and write 4. That's this that you're doing right here that I'm highlighting. And now what's the next thing that weapon does? Or excuse me, that the knight does? Ask the weapon, did I hit? Go ahead and ask the weapon.
Did I hit?
And then what does the weapon do? Ask Todd what? Get. Go ahead, go ahead. This is my big moment.
Get.
45! All right. So I throw back 45. Is the random number less than or equal to the hit chance? No. So what do you return back to the knight?
False.
And then now what do you do with the false?
I return it to him. So
Yeah? So note how easy it is for main. Main just simply said attack and just sat there until a true or a false came back. It was false, so the other knight is not knocked off the horse. Let's do it the other way really quickly.
Stamina? 4.
So gets a stamina. 4 came back. What do you do with the 4?
Return or store. I mean, add
You subtract it from the 10. Yeah.
6.
So that becomes 6. And then what's the next thing you do?
Hit.
Yeah. Did I hit?
Did I hit?
Asking of the weapon. And then what do you do? Ask me. And I say 2.
Oh,
All right. So true comes back to the knight. The knight returns true to main. Since it's true, what does main say to the other knight? All right. Fall off your horse. Exactly. And so there's one more line that we do here. Let me get this out of the way. And that line is to just come this way to Stormy and say, unhorse yourself. All right, we'll pick it up on, what's today? On Friday, we'll pick it up. All right, thanks a lot. I appreciate it. Thank you. Thanks.